Good morning, everyone. Welcome to the Hellisheidi power plant. On behalf of On Power and Reykjavik Energy, I'm very happy to see you all here at this event. Hellisheidi power plant produces about 300 megawatts of electricity and about 130 megawatts of hot water for district heating in Reykjavik. It is the largest geothermal power plant in Iceland, and we're very proud of it. Here we've been working on an R&D project for a decade where we're turning CO2 into rock. It is an effort that we're extremely proud of. It's given us a tremendous amount, both in progress for our own processes, but also for our scientists working here. And so after the event, I'd like to, before we embark on the tour, I'll go over some safety instructions, and we'll invite the media and anyone else interested to go and see what the process looks like. But we'll look at a short safety video first. But enjoy your time here. It's a pleasure to see you all. Thank you.
Good morning to you all. For me, this morning is to some extent a historic landmark on a long journey, and potentially it could become a revolutionary moment in the battle of mankind against climate change. I know it's a strong statement, but in essence, this is what it is all about. It was over 10 years ago that I was privileged to join hands with Jeffrey Sachs, who then had recently moved from the John F. Kennedy School of Government to Columbia University, to the Earth Institute, in a dialogue which 12, 13 years ago was aimed at trying to convince major business corporations that climate change was a problem. And although many of us have been frustrated in the general international dialogue about climate change, I think it demonstrates an extraordinary progress from that situation to the Paris Agreement 2 years ago, and to the extensive involvement of most of the leading global corporations in that effort. But let's not forget that although we usually talk about Paris as a climate conference, it was in its essence an energy conference. Because without a comprehensive energy transformation, the vision of Paris will simply be empty. And in this dialogue over 10 years ago, Wally Broker, who was the grand old man of climate scientists at Columbia, his claim to fame in the 1970s was that he discovered and pointed out to the world of science the conveyor belt of ocean currents. And I've often used that as an example of how ignorant we have been about our planet and how recently our knowledge of some elementary forces have become available, that before Wally discovered the entire global conveyor belt of ocean currents, we didn't know about that important aspect and its influence on weather patterns and the climate all over the world. So he was really the grand old man of climate science at Columbia University. And he came to Iceland, and in the old library at Bessastaði, the president's residence, we had a dialogue with some scientists from the University of Iceland about the idea of turning CO2 into rocks. Pumping it down into the ground and letting it touch basalt and turning into rocks. So this whole debate, which was then quite strong, that the CO2 would escape, even if we pumped it down into the ground, was being tackled head-on by pumping it down into the ground. And Reykjavik Energy was enlightened enough in its leadership in the city of Reykjavik to agree to open this area where we are here now, which at that time didn't look as a splendid demonstration of clean energy power as it does today, up to this experiment. So to cut a long story short, as will be explained later on, scientists from the University of Iceland, the University of Columbia, and the University of Toulouse in France came together at the hospitality of Reykjavik Energy, which their scientists and experts and engineers at Reykjavik Energy to create the Carbfix project. And I want to use this opportunity here today, especially in the presence of the mayor, that despite all the ups and downs we have had in Iceland during those 10 years, the financial crisis, the struggle to maintain the solid business ground of Reykjavik Energy, and the ongoing continuous changes in the leadership of the Reykjavik City Council, this project was always maintained. And for those of you who have come from afar to the prosperous modern Iceland we have today, a leading example of a successful economy, it's hard to imagine the environment of crisis that was here in 2008, 2009, 2010, 2011. And there were a lot of projects cut and eliminated from various budgets, both from the government and the city during that time. But the Carbfix project stayed. And I hope in the future some historians will pay tribute to the visionary leadership of Reykjavik Energy and the city of Reykjavik to have maintained that project despite all the struggles that were then going on. So, as will be explained later, it then became a foundation for scientific cooperation, for PhD students, and for a success of practical science and a new vision of how to deal with CO2 in the atmosphere. And as we all know, the CO2 goes all around the globe. And my vision at that time was to create what I call pumping stations all over the world, where there is basalt, like here in Iceland, in Russia, in the United States, India, and elsewhere, to take the CO2 wherever it originated in the world, and thereby making a major contribution to our common human battle against climate change. But there was one link missing. That was, how do we take the CO2 from the atmosphere? And as yet another example of how coincidentally people are brought together, in November of last year in Marrakesh, at the first COP meeting following Paris, under the visionary convening of Amazon Collective, which Lauren Jobs established a few years ago and is now headed by Andy Kastner, who will be here tomorrow in this room, who was previously one of the leaders of the Energy Department of the United States. They brought together in Marrakesh, on the sites of the COP meeting last November, a gathering of some of the leading thinkers and experts in the field of energy and climate to basically answer the question, can we secure the success of Paris even if governments fail? It was perhaps a convening a little bit inspired by what was going on in US politics, but it was also a fundamental question that now we might have the technologies and the frameworks to execute the success of Paris and thereby save the world's climate irrespective of what governments did. And that was a revolutionary thinking, because up to that time, from Rio through Kyoto to the failure of Copenhagen and the success of the Paris Agreement, the assumption was always we need international treaties, we need governmental leadership. But now cities, as well as companies and universities and centers of innovation, could perhaps provide the solution, even if leaders of governments and ministries were either inactive or even in opposition. And there, in this beautiful hotel close to the desert in Morocco, a few miles from where the states were meeting at the COP21 meeting, we sat down one evening with Julio and Christoph to explain his innovation of capturing CO2 from the air, and I explained the Carbfix project in Iceland. And they then traveled to Iceland and came here a number of times. And once again, Reykjavik Energy had the enlightened vision to make an agreement with these rather strange innovators who said they had discovered this technology and allow them to test it out here at this, what I think is the most fantastic demonstration of clean energy anywhere in the world. If you need a lesson to anybody about clean energy, bring them for 5 minutes up to this power plant. And here we are today. And as all of you know, I mean, technically I don't know very much about energy. Technically I'm rather ignorant about climate. But I've been trying to bring people together over a long time who know what they're talking about. And so far, they have all delivered. And it's on that assumption that I am here today, that you will actually deliver. And you have set up this demonstration model. And unfortunately, because of my engagement leading up to the Arctic Circle Assembly, I can't be with you when you show it this morning, but I can assure you I will make a special trip up here to take a look at it, and it will be shown to the Amazon delegation that will be here tomorrow. And it's an interesting story that Steve Jobs' widow and Amazon Collective will be in this room, and not her, she's coming on Friday. But it shows the connection between the information technology revolution and what we are doing here today. And as I've sometimes said in recent months, when you work with the people from Silicon Valley, for my generation, it's a fascinating experience, because those people have lived the story of young innovators coming out of garages and within 15, 20 years revolutionizing the world with their technology, whether it was Bill Gates or Steve Jobs or Mark Zuckerberg or whoever. And to some extent, in my view, what's happening here today could be for the climate and the capturing of CO2 a similar transformation. Because if this works, then one can create what I call these pumping stations all over the world, where you have the similar geological conditions, and take the CO2 wherever it originates in the world, whether it originates in China or Russia or in San Francisco or wherever, and eliminate it gradually from the atmosphere. Can it be done? I believe very profoundly that if this works, it can be done. And if you have seen the movie Social Network about how Facebook was created, then see it again. And during that viewing, only think about when does it take place. It begins in 2003, where these guys up at the universities on the East Coast wanted a program to meet girls. And it's fascinating when you think about it and seeing the movie that is only 14 years. And now over 1 billion people all over the world use that technology for their social transformation, economic transformation, scientific transformation. So those who have come here from afar here today to add to the Carpfish project, this new, hopefully revolutionary technology, and those who have worked here in Iceland for more than a decade on the Carpfish project, to combine the two in a successful way could be a game changer in the fundamental way in the battle against climate change. And I know these are strong words, but in this long journey, since the first conversation about this more than a decade ago, everything so far has shown that the scientists and the experts that have led this effort have turned out to be right. So therefore, I congratulate all of you. It's been an honor and privilege to be a part of this journey. And if, as you have promised, this is going to work, I can assure you there will be a lot of people who want to take this forward on a scale that we have not, most of us, seen before. Thank you.
Thank you very much. Herra Forseti, Olafur Ragnar Grímsson, other distinguished guests. It's an honor for me to be with you here today on a number of points. Firstly, I'm very proud of the fixed project, and it continued success. We recently received the news that the Horizon program was deciding on a huge scientific and research grant, probably one of the biggest in Iceland's history, from the European Union to back this up. And we're at experimental stage, but we come so far, so we know that it's extremely exciting. So we're all here watching what you're doing and hoping for the best, but we're also believing in it. And as a city, we believe in this project on a lot of levels. First, we're a green city that focuses heavily on climate, being a green city with a blue ocean outside it. We also believe in international cooperation, and actually Mr. Olafur Ragnar Grímsson has been kind of a single-handed catalyst of a lot of international cooperation when it comes not only to climate, to cooperation with the city and the Reykjavik Energy, but also, as you see now during this weekend, when it comes to the Arctic, where you have all these things interconnected. The climate issue, economical issue, preservation of nature, and science and technology and the investments needed to deal with all these issues. But for a city and a mayor actually that believes that in the future you will only have two types of cities, you will have university cities and dead cities. This project is also of great interest because it combines Reykjavik Energy, the energy company and heart of the green city, and the University of Iceland, also the University of Columbia and Toulouse, and even cooperation from Barcelona, that creates exciting opportunities for young people that want to make a difference, want to find out something new, want to be in the front line and world leading. And that in itself is very interesting and exciting for Reykjavik as a university city. But as well, this is an extremely interesting example of public-private partnership, where we as a city and a public company are working with world-leading not only universities but companies and Climeworks from Swiss, which we welcome very much to the site, into this project, to develop it and combine their technology with the experiments and progress we've shown here in recent years. So I'm just taking up the point from Olafur Ragnar, very proud, but also cautiously optimistic. I think and I agree that if this will success and if this will be scalable on a large scale, this can be extremely, extremely exciting and important. But I know as well that we will get a lot of extras out of this, knowing more about the site and the plant, knowing more about how all these things interact, and maybe we will get a lot of spin-offs we don't have a clue about today by combining together the hearts and minds that have created this project and will lead it forward. So thank you very much. I'm actually going to put some even added pressure on Climeworks. I don't give out red roses easily. And those that get them from me, they just have to deliver. So, please, Climeworks.
It's a pleasure to be here today. You can see the title of my talk, Turning the CO2 Troll to Stone. Icelandic folk tales, they tell us the stories of how trolls that roam the hills and mountains here in Iceland are turned to stone when the rays of the early morning sun shines upon them. And these are stories us Icelanders are very familiar with and well connected to. And because of that, the Carfix team relates particularly well to these stories, because what we are actually doing is we are turning yet another troll, not the conventional Icelandic folktale troll, but the CO2 troll, permanently to stone. And this is something that we have been working towards developing for the past 10 years. And as I said, it's a pleasure to be here today with Mr. Mayor and President Grímsson to embark upon a yet a new chapter in this very exciting tale of ours. But as we are here at Hellisheidi geothermal power plant, I just want to start with a very short introduction on what geothermal actually means to us in Iceland and how it relates to Carfix. Geothermal actually is responsible for heating 9 out of 10 houses in Iceland. However, its utilization is not without challenges. You can see the emissions coming here from a typical well, and also what's rising from our cooling towers here in the back. And this is 99.5% water vapor. But the remaining 0.5% is geothermal gases. And there, CO2 is the most abundant gas. And in a power plant like this, 300 megawatts electricity, 133 megawatts thermal, we are emitting some CO2 that is originated from the magma below us. But keep in mind, we are still a very green energy source, and our emissions only account for about 3% of what fossil fuel burning power plants of the same size emit. But, as you know, and as has been explained, we have been working towards reducing these emissions over the past 10 years through the Carfix project, where we capture otherwise emitted CO2, inject it back into the ground, where it comes in contact with basalt, and chemical reactions take over, turning it into rocks in less than 2 years. And this is the chemical equation. I'm a chemist, theoretical chemist actually, so I love showing chemical equations, but here I just show it figuratively. We have the basalt interacting with the CO2, which is dissolved in water when we inject it. And when this water phase comes in contact with the basalt, it dissolves the basalt, releasing calcium, magnesium, and iron, which is part of the primary basalt. And we can form this instead. So it's already been explained how the project actually began. And I don't really have much more to add to that. But as President Grímsson said, we started back in year 2006 when Wurzbacher came over after being invited from President Grímsson to give a fight on the talk against climate change. And after that, scientists, Reykjavik Energy began discussions on how we could join forces to develop the method and bring it to life. So the project was formally founded in 2007. I really like this news clipping. It's from one of our daily newspapers. It's from early January 2006, the day after Wally gave his talk. Here we have Wally, here we have President Grímsson, and most of the primary scientists in the Climeworks project. And for those of you that not understand Icelandic, it's say that Icelanders to become pioneers in carbon capture and storage. And perhaps, this might become true. This is just a very brief project timeline. So we started in 2006. When the idea was born, founded the project in 2007. Then we were in preparation phase, design, lab testing, developing monitoring methods, because it was by no means straightforward how we were going to prove that we were actually mineralizing the CO2 we injected. Then we carried out test injection in 2011, and the actual pilot phase injections were carried out in 2012. Then a long period of monitoring took over, but rather early on we were able to demonstrate and see that the process was working as we anticipated it would, and CO2 was very quickly turned into stone. So based upon that, we decided to scale up here at Reykjavik Energy. And now carbon capture and storage is an integral part of everyday operations here at the power plant. It's just an automatic process and will remain that way as long as the power plant is in operation. So as I said, we were able to show and prove that the process is working, and the results were published in Science last year. And the fact that we are able to mineralize permanently CO2 in only 2 years, less than 2 years, it was a game changer for carbon capture and storage. Because up till then, carrying out carbon capture and storage in the conventional way, where CO2 is injected as a supercritical gas phase, it had believed and it had been reported that mineral trapping would only occur in hundreds to thousands to tens of thousands of years. So doing it in 2 years was a complete game changer. And along with the paper we published in Science, they followed an editorial piece that encouraged us to, based upon these results, inject, baby, inject. And that's what we've been doing since then, and will continue to do, as I said. And this is a picture showing Hellisheidi power plant, exactly where we are here. And I want to emphasize what we had to add to make carbon capture and storage part of our operation. So what we added, it was this building here. And this is the gas separation stations that separates CO2 from other geothermal gases. And of course we did some additional piping and so on, but this is the main added footprint of the operations. And you can see it's tiny. Just very few words about the process. We have our production wells where we get a mixture of geothermal water and steam, separate the two phases in separation stations, take the steam phase through the turbines, and the gas, geothermal gas, it travels with the steam phase. Then, after the turbines, we remove the gases from the steam, take them to the new gas separation station, and there the gases have a shower. So it's very simple, because CO2 actually dissolves in water. So it's basically just a soda stream machine. And we take the soda water after the gas separation station, inject it back into the reservoir where the CO2 came from. And this is basalt hosted, so the reactions take over. And from the beginning, we have now injected and mineralized about 18,000 tons of CO2. And that corresponds to emissions from burning approximately 60,000 barrels of crude oil. So what are the worldwide implications? Can the method be applied elsewhere? Yes, it's already been covered by President Grímsson, that wherever we have basalts and a CO2 source and water, the method can be applied. And about 5% of the continents are made up of basalts. And then we have the ocean floor. And the ocean floor, of course, is, to many respects, very favorable. We are not ready to jump into ocean injection today, but based upon how quickly we got to where we are today, compared to 10 years ago, who knows what happens in 10 years. And the beauty about the ocean floor is there, of course, you have a lot of water. You have an endless source of water. Because if you're going to carry out the injection method, the way we are doing it, dissolving the CO2 in water, you need a lot of water. And there you have it. Enough water at the ocean floor. And so this is something that we are continuing to, are beginning to look at now in this new EC grant that we, the EU grant that we got recently, prepare for ocean activities. That will mainly be the scientists at the universities that embark on that journey. But another very important aspect of this new journey we are starting here today is the path towards negative emissions. And here we have a picture from the pilot phase operations in 2011. This was our pilot gas separation station. Doesn't look like much, but it got us where we are today. And now, in comparison, we are starting yet a new pilot scale demonstration in collaboration with Climeworks. And we're very excited about this. And I believe something great can come from our collaboration. So that was all I wanted to say at this point. Thank you for your attention.
Dear President Grímsson, dear Mayor Eggertsson, dear Carbfix partners, dear ladies and gentlemen, it's a great pleasure to be here. And as mentioned by President Grímsson, we met less than a year ago. It was 11 months. And I'm very proud and happy to announce that in 1 year we were able to build a plant, to install a plant in Iceland, to acquire funding by the European Union to support this project, and to bring it online. And I'm very moved and excited that last night was the very first time that a machine took CO2 from air and provided that CO2 for underground mineralization. And I think that's the reason why we're all here. So what is Climeworks doing? Climeworks builds machines that capture CO2 from the air. As simple as that, we take in atmospheric air and provide air without CO2 as well as high purity CO2. Why should you be so stupid and capture CO2 from the air? When Jan and I started this company 10 years ago, we had many critics and no one believed that this could be relevant. The reason it's relevant, we needed to achieve climate targets. Actually, 87% of IPC modeling scenarios consistent with a 2-degree temperature goal assume carbon dioxide removal on a massive scale. If we were to achieve the 1.5 degree target, which we hopefully will, 2 degree side note is really bad. So if we were to achieve 1.5 degrees, the importance for carbon dioxide removal will be much more than shown here. So what do we need to do in order to achieve climate targets? There are 2 things. First, we need to bring CO2 emissions to 0. So if you talk to your families tonight, recall 2 things. First, bring CO2 emissions to 0 by mid of the century. This is done in a large part by traditional mitigation means like renewable energy, energy efficiency. However, you will never come to 0 without carbon dioxide removal. For example, battery electric vehicles have a carbon footprint, even if powered by wind energy or geothermal energy. And in order to bring those emissions to 0 gram per kilometer, for example, carbon dioxide removal is required. So what we're doing here is important for the journey even to come to 0. And once we reach 0, we have not reached our goal. We have emitted too much in the past. We have done too much damage. Most people don't know that climate change to date is 1 degree Celsius, and the last time the climate was 1 degree warmer, we had a sea level rise, or the sea level was 6 to 9 meters higher than it is today. It's just a matter of time when we will have this sea level rise. Also, with the current CO2 we have in the air. So what we need beyond becoming carbon neutral is become CO2 negative. So our kids and grandchildren will live in an economy or in a society where we are not emitting 36 gigatons of CO2 per year anymore, but we are subtracting 10 or 20 gigatons from the atmosphere every year. And this can only be done by carbon dioxide removal. Carbon dioxide removal by direct air capture faces two crucial challenges. On the one hand, capturing CO2, wherever you capture it from, be it a combustion flue gas or the air, requires a lot of energy. So you want to have access to low carbon energy to drive your processes, first. And second, in order to remove carbon, you need permanent and safe storage of CO2. The beauty of this site here, and this is what President Grímsson outlined when we met in Marrakesh, and this is what drove us to complete this plant in 1 year, work 2-shift operation, that all we can do to make this happen is that we can find this here. We have geothermal heat in abundance to drive our process, and we have maybe the safest way of permanently storing CO2 in a safe manner here at Hellisheidi power plant. So, since we're two, Jan will add a couple of words.
We were talking a lot about scalability today. So what we started here on a very, very small scale, we want to do on a large scale. How are we planning to do this? In May this year, that was also a very important moment for Christoph and me and for Climeworks. We set into operation our very first commercial CO2 capture plant back in Switzerland. And you see a picture here. And this should be a picture that could be very soon happening around the corner here as well. As you see there, the Climeworks plants are based on a modular system. You see 18 of these CO2 collectors here. One of this is here now. And this is our concept we are following. So we need basically three things at scale. We need the machinery to take the CO2 out of the air. We need the energy supply, and we need the storage space. So the latter two, we have them here. We have heaps amounts of basalt rocks here, and we have the geothermal heat, which we need. And in order to scale the facilities, we are following this concept. We are currently able to produce on the order of 100 of these CO2 collectors per year. And we are now thinking how to do 1,000, 10,000, and 100,000 of these. A couple of words. Who are we, or where do we come from? The history of Climeworks is already 8 years old as of today. Christoph and me, we started back in 2009 as a spin-off project of ETH Zurich. Founding Climeworks, starting the two of us in small laboratory experiments until we got to the first demonstration scale. It was 2011, 2012. Since then, we have raised about $20 million in equity and in public funding. Part of that is also part of this CarbFix project. And we are currently 45 people working on the scalability of CO2 capture directly from the air. So now, where do we stand today? 3 months ago, that was very important for us. That was the first commercial plant we set into operation. Today might be even more important. Because, as Chris mentioned before, yesterday night I got this telephone call. We injected for the first time atmospheric CO2, and we did it at a 50-ton per year scale. So the purpose of this is now understanding how this works. We learned many of our partners of Reykjavik Energy and On told us, really don't underestimate our Icelandic climate conditions, don't estimate our winter. So we will learn in the next couple of months what is going to happen at 100% relative humidity and minus many degrees. So this is our big job to do. And based on that, we are planning the scale up here. So during the next year, we are trying to find first customers for negative emissions. So there are many companies, foundations, private individuals around who have set their corporate sustainability targets and said I would like to be carbon neutral by 2020. 80%, 90% of that I can do today, but the remaining 10% I cannot get around them. and then paying for negative emissions that actually extract carbon molecules out of the air and extract them in the rocks up here, that could be a business model to start and to finance the further scaling that we need. So that's our job and our homework for the next year to do. And for 2019, I put a picture here. Well, this is the only picture we have of our scale plant with 18 of these CO2 collectors. It might even be bigger. We are currently thinking of a scale of 3,000 to 5,000 tons of CO2 per year that we are aiming at. So that's the plan where we are heading to. That's not the end. We have set ourselves a very, very ambitious vision, which is really ambitious. We call that in two figures, 125, capturing 1% of global emissions in 2025. That would mean we need to triple our production capacities once every year from now, which is very ambitious, but that should show basically the main keyword that was the topic of the day, that what we are doing together with Reykjavik Energy, that is scalable. And I would like to end up saying that it's a great honor what we've heard before. I think this is the first time I have received such a bundle of red roses in my life. And you put also a bit of pressure and expectations on that. And well, I will promise we take your words seriously. Thank you very much.
I apologize, as a geologist, I have to have rocks with me at all times. Thank you. It's such a delight to be here, in no small part because today there's something new on the planet, and that's a miracle, and we need to note these things. It is often easy to be casual about the miracles in our daily lives. I read the other day, somebody's invented apparently a spray can. You can spray on any surface and make it a touch screen. That's a miracle. It didn't exist last year, it exists this year. Same thing can be said about this plant. As I was introduced, I call myself sometimes the carbon wrangler. I get up every morning and what gets me out of bed is thinking about tons. It's just that simple. Just think about tons. We've put tons of CO2 in the atmosphere and we got to do something about that. And every year we add 40 billion tons of CO2 to the atmosphere. That is 80 times what all of people on Earth weigh. It is a lot of carbon dioxide. 80 times the mass of humanity we put in the air. Since the Industrial Revolution, we have put 2 trillion tons of carbon dioxide in the air. That is a very big troll. We have a 2 trillion ton troll that we have to manage. And it's our job. We have to clean up our room. We don't really have an option. My kids don't have an option when they have to clean up their room. We don't have an option. We have to clean up our room. It's just that simple. And we only need a few things to do it. We need technology that can do the job. We need policy that helps set the incentives and the frameworks for that. We need finance to build the projects, to get them done. And we need customers. We need people to want this. We need people to want this because it's a virtue, because it has value in their lives. And all of these things end up coming together in another thing that we need projects. We need places on the world where people come together and they do something, and they build something, and they make something happen. And the reason that I'm here, and the reason that I'm so delighted to be here, is that projects like this are extraordinary, and the people who pull them together are extraordinary. In this case, we have 2 different extraordinary groups. This is a Reese's peanut butter cup of awesomeness. We've got 2 great tastes that taste great together. We've got, Climeworks, which have brought together 2 things, one visionary and one practical. Well, they said we have to create this economy that doesn't exist, and to do so, we're going to do the slow boring of boards. We're going to be engineers. We're going to sit down at tables and schematics and make things that don't exist. This has come together with another visionary, an extraordinary group in the form of Reykjavik Energy and the CarbFix project, which has shown sort of global leadership and real international leadership in climate and science and technology, and combine that with a basic corporate responsibility, where they said we've got the lowest carbon emission power plant in the world, and that's not good enough for us. We actually have to be even lower than that. That's part of our responsibility as people. That's part of our responsibility as a company. And by combining this thing that's visionary and practical in one sense, and a combination of leadership and responsible acting together, we've actually are making one of my very favorite things, which are rocks. And that's also extraordinary because people don't often think about it that way. And I also have rocks, and these came from the display case out here. I promise they'll go back. But this is this beautiful Icelandic spar, and this is made of nothing but calcium ions and carbon dioxide. That's it. And like a tree makes wood out of carbon dioxide, we make rocks out of carbon dioxide. And something which as a scientist is extraordinary, and it's so extraordinary and miraculous, I just have to show it here. They've shown how fast it happens by drilling it and pulling it out of the ground. And Edda Aradóttir and Sigurdsson, Hilfaksson, and these other people have pulled it out of the ground to show us. And this little white sheen of minerals here with a tiny bit of green dye in it was made from the carbon dioxide out of this plant. They put it underground and the earth turned it into stone. And what's remarkable is that this happened within a month of injection. It was very fast. So as Edda said, within a couple of years, we know that this happens. And we know that this happens here. And that's good news because it probably happens in other places. This is scalable and this is reproducible. And I really do believe that Hellisheidi is going to become synonymous with this kind of miracle. It will be a global touchstone for clean energy and for the environmental movement in ways that we don't yet understand, but which we will ultimately see manifest. The work that we all face now is deployment. We have to build things and deploy things. We have to have thousands and thousands of these units out there doing this work, and that means projects, and that means finance, and that means deployment, and that's just the work. That means we need to grow the customer base. We need to get Reykjavik Energy and Climeworks more customers. I want to see this become so big that Reykjavik Energy has to double its geothermal production to provide the energy and hot water necessary to do this work.
Slow down.
And I want that to be financed with money from around the world for people who say, I want to be part of that. I want to see these things made. That's what we need. I want the customer base from around the world to flock to Iceland to see the miracle that's here and to put their money into something that's noble and remarkable and necessary. It's just what we need. We need 1 million tons a year here. We need 100 million tons a year in a couple of years. We need 10 billion tons in 30 years. It's the work, it's the math of climate change. We need 10 billion tons of CO2 to come out of the air starting about 30 years from now. And that means, the best time to plant a tree is 20 years ago, the second best time is today. And so we've planted the tree today, it exists. It's real. There is something new on the earth. It wasn't here a year ago and it's here now, in part because the people who are in this room have shown the money and the leadership and the passion and the excellence to make it real. This plant and this site is going to be important for the future, but even more so, it's important for the present. It's important for today. And I'm delighted to be here to be part of it. Thank you all.